Hello! Today I'm going to talk about practical application of microphones. This isn't something you really should need to know as an electronics technician. After all, you work with circuits, you are not a sound engineer. But as an electronics technician, people expect you to know everything remotely related to electronics. So you might find yourself being asked to work with an audio system sometime. And if you have a little bit of foreknowledge, you might save yourself a little work or make yourself a hero. So the first thing you need to know is, are you working with a high impedance microphone or a low impedance microphone? High impedance microphones tend to have impedances of around 10,000 ohms, and low impedance microphones tend to have impedances below 1,000 ohms, typically around 600 or below. They're usually specified at about 600 ohms. But what you need to know is it high impedance or low impedance? And chances are, in a recording situation, you're going to find yourself working with low impedance microphones. Now, matching microphone impedance to a circuit is not the same as with radio, which we will talk about down the road, because we don't want to match our impedance. We actually want our microphone usually to go into a much higher impedance than the microphone itself. So a low impedance microphone of perhaps 100 to 600 ohms is probably going to go into a mixer with an input impedance of maybe around 10,000 ohms. So why is that? Well, remember, in series circuits, if we have a voltage divider, here's two resistors, which represent the impedance of the microphone and the impedance of the mixer input. And let's say these were equal. Let's say this was, let's just make it 1K and 1K. So this is going into the mixer. There's our common ground. That is coming from the microphone. And if this was the situation, well, what's going to happen to the voltage here? We know that if we have equal resistance in our voltage divider, we end up with our voltage divided by a factor of 2. So if this is 1 millivolt coming in here, it's going to be 500 microvolts by the time it gets to the input circuitry of the mixer. So we really want this to have a much higher impedance. Let's make this, let's just keep it 1K and let's make this 9K. So now what's going to happen to our voltage when we go from the microphone to the input of our mixer? Well, this is a 9-to-1 ratio, so our voltage will be a 9-to-1 ratio. So we have 1 millivolt here. We'll end up with 900 microvolts making it to the input of the mixer instead of only half of that. So in reality, we're going to be maybe around 600 ohms and perhaps something around 10,000 or more. And I'm not going to do the math, but you can see this is going to be a little higher voltage. So we want to maintain our voltage going from one system to the other. So low impedance to high impedance. Remember when I talked about impedance, that going from a low impedance to a high impedance is generally good. The big problem would happen if we went from a high impedance microphone to a low impedance input. In that case, we are going to get a very poor voltage transfer, and we're going to get very, very low voltage here. So typically a high impedance microphone going to a low impedance input, you're going to have a very low level. A low impedance microphone going to a high impedance input is typically normal. Although if you have a low impedance microphone going into a system that's expecting a high impedance microphone, you're probably going to get too much voltage and get some clipping. But once again, when you're working with a recording system, like if you're in your school or church or whatever, and they say, hey, can you operate our sound system? You're probably going to find nothing but low impedance microphones, high impedance inputs, and some other things I'll talk about in just a moment. So you don't need to worry about that too much. So that is out of the way. So let's talk about now what's going to normally happen. You have a mixer with a bunch of inputs, and those are for your microphones, and typically your microphones will be low impedance, and so there's no problem. That's what that is made for. These are made for microphone inputs. And so you're all ready to go. You got your microphone set up, and here come the people with the musical instruments, with keyboards and guitars, and who knows what else they might come up with. And guess what? They are not made for microphones. So what you're going to need is what's called, I believe, a direct box, a matching system to match those inputs to your mixer. I have not worked with these myself. I've only talked to a few people who have, and I don't know if they make mixers with inputs for direct input of instruments other than microphones. But if you have a direct box, it may have something that looks, oh, let's look at it from the top. So here we have inputs and maybe one or two outputs. And you might find that you have high impedance. I'll just make that high, and we'll make low impedance. You might say Z or something like that. Probably just say IMP for impedance or some abbreviation, or might actually have the word impedance. But you might find out that you have inputs for both high and low impedance devices, and your outputs will be matched to the mixer. So they're probably going to be a low impedance output, but we're not going to worry about that because we know they're matched and that's going to work. So you have several inputs and one or more outputs, and so you can match your high or low impedance. So if you have high impedance microphones, low impedance microphones, and whatever. I just want to stop the video here for a second and take a closer look at this direct box, or DI box as they're called. And as you can see, this particular one has 2 high impedance inputs and 2 low impedance outputs, and has the capability of operating in either a stereo or mono mode. I also wanted to point out that we have these 2 switches that say ground lift. If you watch my video on how grounding works, and specifically on the artifacts it can cause in audio and video systems, and in audio systems that would be a 60 or 50 hertz hum depending on where you are. So that can happen if you have 2 grounds that are not at the same place and they interfere with each other, if so to speak. So here we have a ground lift. So if you put this all together and suddenly you find you have hum in your system, you may be able to remove that hum by lifting the ground of one of your inputs. So you get it all together, you get hum, you can lift one ground, lift the other ground, and hopefully that will make your hum disappear. If it doesn't, then you've probably got a bad ground somewhere else. Now back to the regular video. Before I go on, I just want to talk about the types of connectors. There are basically 2 types you will see. Most of your microphones are going to have an XLR connector of some sort, and that's going to be a round shell with 3 connections in there. And this accommodates a number of types of microphones. It'll accommodate, for example, if you have a twisted pair wire inside, which is not at all uncommon because that helps reduce noise. Well, the XLR connector can handle that twisted pair as a balanced load. I'm not going to go into a lot of detail about that. I go into that in other places, but the balanced load has a opposite signal on each wire, and so outside interference, which tends to affect each wire equally. The circuitry is designed to eliminate what is equal in the 2 wires and only allow what is different. And then we have a shield around that, and so we have our differential pair and a shield in those 3 connectors, and you have both male and female connectors. I don't remember off the top of my head which is on the microphone. I think it's a male connector on the microphone and a female on the mixer, but don't quote me because I could have that backwards, so I'm pretty sure I have it right. So it accommodates that kind of connection. It can also accommodate phantom power, and once again, I don't know exactly how that's handled because that's not part of my expertise, but they can be wired for either phantom power or for twisted pairs or whatever are needed, and you just have to make sure that they match what you're going into the input. So you don't want to have phantom power coming out to a microphone that's not designed for that. I talked about that before. The microphone will be wired for phantom power, the cable will be wired for phantom power, and when you get here you just have to do your switching. So once again, I'm not going to get into details on the wiring. I'm assuming everything's all wired up and you've just been asked to do this and you need to know the fundamentals of how to hook things up. Perhaps another video down the way I'll get into some details on the wiring, but not now. So you have the XLR inputs. The other type you have is a phone input, and I'll just try to draw that over here. And it's called a phone input because that's what used to be used in the old telephone circuits. And so it's going to be a plug and jack type system, and this would be typically your instruments would have this, although they might have XLRs, and you would have to have inputs for that. And once again, you may have to use a direct box to connect them. So typically what you're going to do is have microphones go directly into your mixer, and if you have instruments which are going to have the phone plugs instead of the XLRs, those are probably going to go into a direct box so that you can match them to your mixer. And also you may have speakers that some are powered and some aren't. So if you have unpowered speakers, they're going to have a couple of inputs. It may be switchable, a single input that's switchable, but you may have an input that says mic and another one that says line. And if you have a computer with a sound card, those terms may look familiar. And we can figure out what this probably means. A microphone would go in there. But if you're using the line input, that's what's going to be on the other side of this mixer going into other equipment. It's going to be what's called a line level signal. And that line level signal has it depends on who you're talking to, but it has a peak voltage of around 1.2 volts or something like that. And that is what goes between almost everything. And in fact, if you have stereo components at home, you'll see these RCA connectors on there. Then those RCA connectors will be, well, whatever they're labeled, but they're usually line level inputs, unless you have a phono input, not to be confused with a phone. So that's a phone plug here. Phono means phonograph. And if you have a phonograph input on a stereo, that is designed for a cartridge coming directly from the turntable itself, which has no amplification or whatever. And that's going to be the proper input for that. And the most important thing is it's going to use what's called RIAA, Equalization, Radio Industry Association of America. And it uses what's called equalization because a record is going to have noise on the surface. You have pops and clicks and scratches. You want to reduce those as much as you want. And those tend to be at the higher frequencies. So what they do when they record a record is they emphasize the high frequencies. So it's pretty much a linear curve, something I'm not going to go into until I talk about phonographs, but it's a fairly linear curve that the higher the frequency is, the more emphasis they put on the record. So you take that connection directly off of the phonograph into a line input, it's going to sound very, very tinny, very little bass, lots and lots of high frequencies. And so your phono input with the RIAA equalization is going to do exactly the opposite. It's going to de-emphasize the high frequencies and emphasize the low frequencies to the exact opposite of the record. And so when it gets to the amplifier, you will hear something that sounds normal. So the back of a stereo unit will have a number of RCA connectors that are maybe labeled line, probably not, but they'll have inputs for different devices. If you have an older one, it may have, and maybe even newer ones may have what's called tape in or tape out or something like that. Those are also line in and line out inputs designed for using recording equipment. So analog tape is not completely dead. You may find a unit that has both tape in and tape out. Those would be line in and line out, and I'm not going to talk about how they work because that's not what we're here to talk about. But basically it's to facilitate having an output to a tape for recording and an input back from the tape deck for listening. And that would be the tape in and tape out. So, but once again, that's not what I'm emphasizing here. But what I'm emphasizing is that we have line level, which is what goes between all of our equipment, and microphone level, which needs much more amplification. And so if you have a powered speaker, now you have powered speakers for computers. They don't have this, but powered speakers for professional venues will have inputs, and you may have a line input for that which is going between all of your equipment, or a direct microphone input. If you look at a sound card on a computer, you'll find that you have a line or a mic input or something that's switchable, and that would be for the same thing. If you wanted to hook something like this, like a stereo components or this professional equipment into your computer, where would all this go? It would go to the line input. But if you have a microphone, it will go to the mic input for the same reason. The mic input needs more amplification, and the line input is designed for this line signal that I have talked about here. As far as hooking up microphones and such, that's the basic idea. You have your XLR connectors and you have your phone connectors, and they have to be matched up. You have to match up your impedance if there's such a thing. Typically, your microphones will go directly to your mixer, but if you have instruments such as guitars, keyboards, or I don't know what else you might have, but you may have other instruments with direct electronic output, those would probably go to a direct box to match them to the inputs of your mixer. Now once you get to the mixer, well, what do you have? You have well, there's a mixer right there. So what you have is a whole bunch of sliders, tons and tons and tons of sliders, tons of inputs, and tons of equalizers. Who knows what you have? I haven't messed with them too much. I know most of them are volume sliders, but you may have other things that you can control, but that's what it's going to look like. And each one of these represents a channel coming in, and it's going to basically all go out to a line output. And you'll have somewhere along there maybe multiple meters, or maybe just 2 meters for a stereo setup, or maybe even just one. And these are your volume unit meters usually, or VU. And they may be labeled in dBV for volts, or dBu for another type of dB unit. I think that's for dBu is actually based on the letter mu in Greek for micro. So dBu would be based on microvolts. But in reading up on that, I was reading a lot about what's dBV, what's dBu, what's dBm, what are these different dBs. I talk about that when I talk about decibels. I'm not going to talk about it here because the more I read about it, the more I was convinced that the person talking didn't know everything they were talking about, because some of the things didn't add up. And so I thought, I'll bet that when it comes to all of your different types of decibels that you're working with in a sound recording environment, what you need to know is keep the needles out of the red. So if you look at one of these meters, you're going to have a scale, and it's going to go, and up at the top end, there's going to be some red, and somewhere around here is going to be, I'll just write it down here, 0 dB, and that's going to be negative decibels. I don't know how many, let's just say 9, negative 9 dB. And that's going to be 0 somewhere up here. And when you get to the red, that's going to be positive 3 decibels. Because at 0 dB, that's when everything is at its maximum. Our sine waves are being amplified as far as they can. If this is a line level input, that's going to be something like a peak of, I think, 1.22 volts or whatever. If you go any higher, you're going to start chopping off this top. And it's going to introduce odd harmonics. It's called harmonic distortion. It sounds terrible, but it really doesn't become audible until you get 3 dB above this point here. You just keep everything, maybe ideally down below 0 dB, because you want to keep it below that reference. Why is it 0? Well, as we talked about before, it's just a reference. That is what we want as our norm, and anything less is going to be negative decibels. Anything higher will be positive decibels. I guess I could put a little dB here to remind us that that is decibels, minus 9 decibels to plus 3. And so keep your needles out of the red and you won't hear audible distortion. So I was suspecting that that's what you need to know. So I talked to someone I know who is an audio technician, and I asked about this. I said, what do you need to know about all these different types of decibels? And he said to me, all you need to know is keep the needle out of the red. So there you go. So you'll have these meters. Often they're labeled VU for volume units. They might be labeled dBm. They might be labeled dBu. Doesn't matter what it's labeled. Keep the needle out of the red and you won't have any distortion. So that's what these different sliders are. You have your different inputs and you control your sliders. And whatever you're doing, you want to control how much is coming in. You want to, like some things, you might want to give a little more emphasis than others. And if you have multiple meters, you can use that to perhaps equalize things. But the main thing is, don't let your needle go into the red to avoid distortion. Now, some other things you may need to know, just some practical application. If you're working with a small number of microphones, let's say you want to do a stereo recording. I'm going to think about a symphony orchestra, but it could be any kind of group on the stage. And so here's our stage. And symphony orchestra, we've got our conductor in the middle, and we've got our violins over here, violas, cellos, basses, woodwinds, horns, usually around here, the brass, usually there, and percussion over here. Okay, so that's what you got. You've got your orchestra lined up there, and you want to record this in stereo. Now, in a professional studio, what they're going to do is they're going to drop microphones all over the place and try to get them close to the instruments. and they'll have that mixing board and they'll try to balance that, and I suppose the conductor would be listening to make sure things get balanced. In fact, what they're going to do is do a multi-track recording so they can change the balance after the fact. So they might have something like a 16-channel recorder. They used to have 16-channel tape recorders. Now you might have a, who knows, a 32-channel digital recorder. But I don't know. I've worked with these. Do they have 32 channels? I don't know. But 16 channels, I'll bet they do, because that's what they had in tape recorders at one time. And so that can be mixed after the fact. So that's going to be your best setup, is to have lots and lots of microphones close to the instruments. You're going to eliminate a lot of problems such as phasing, because the microphones are close to the instruments, so they don't pick up other sounds as well. We don't have the issues of the timing of reflections off of whatever, because we're not going to get any other sounds other than the instrument they're trying to pick up with the microphone, or the small group of instruments is going to be well attenuated because the microphones will be close, and that eliminates a lot of problems. But then you need the skill to mix that together to make a good stereo recording. They can do a very good job. I find a well-engineered stereo recording working this way is equal to what I talked about before in binaural recording, which, even though I said I can't really tell the difference, I think intuitively, I think that the idea of having the microphones inside the fake head is going to make a very realistic type of input for what we hear, but this is equal to it and is more controllable. However, you may not have the luxury of all that mixing or the skill to do the mixing, so what you're probably going to do is work with two, or just a small group of microphones, mostly two. So like I said, in binaural recording, what they do is they actually put two microphones inside a fake head. If I can draw a fake head here, where the ears go, and that's going to give you a sound that's very similar to what a human's going to hear, especially if we make these cardioid microphones so that this one tends to pick up sounds in this way and that one tends to pick up sounds in that way. Actually, I don't think they do, because of the idea that the mics are embedded inside the head. I've listened to some recordings using this technique and they sound pretty dang good. I just can't tell the difference between one of these recordings and one that's made with the groups of microphones and well mixed by a skilled engineer. So this may be something to try if you need to make this kind of recording, but you may not have that option either, so you may just have some microphones to set up. Where are you going to put them? I would like to put the microphones well separated. The problem with that is you're going to get phasing issues. Sounds are going to hit this microphone from here before they hit this microphone from there, and sounds that echo off the side of the stage or back of the hall or wherever you are going to hit at different phases. And this has a problem of causing emphasis of some frequencies and de-emphasis of others. And it doesn't sound particularly bad, but it's not the best way to get the sound, because it's not going to sound quite right. So probably the best idea is to put your microphones close to the center and use a couple of cardioid mics. And so I'll just show a couple of cardioid mics here. There's one pointing that way, and have another one pointing that way. And remember, the cardioid mic is going to pick up very strongly in this direction, weakly from the back, and less to the sides. So it's going to have a pickup pattern. I'm going to try to draw this pattern so that it goes through the instruments. So it's going to look something like this. That's kind of terrible. There we go. And notice it's going to pick up these instruments fairly equally, but it's going to drop off over this way. And this one's going to tend to do about the same thing. So that's probably a preferred arrangement for microphones for a amateur to be able to set up only two microphones. I've tried other setups. I've found some success by putting a microphone over here, pointing roughly in that direction, and another microphone over here, pointing roughly in that direction. That's going to pick up very strongly here, very strongly there, but it's going to have the pickup, once again, in the area over here that's strong, like that. But that's going to give you better separation, but probably going to have some problems with the instruments in here, mixing them in right. So I don't know if that's the best way or not. So probably for someone that's just setting two microphones up, this arrangement's probably the best. Some people might actually put the microphones more like this, pointing in different directions. I don't know if one's really better than the other. Another thing you might see is a device, and of course I can't remember what it's called right now. I'll put the name of it up there and a picture of it. But basically you have a sound absorbing material here with your microphones on opposite sides of that. That way you have your cardioid pattern that picks up like this, but then it drops off because of the sounds being absorbed here. And you get the sort of the same thing over here, and it once again drops off. And that will tend to make your stereo separation a little better. One thing that keeps coming to mind that can really mess up your stereo separation is if your microphones are arranged such that some sounds come out 180 degrees out of phase. Because what that's going to do is make the sound, you can hear it, it doesn't completely get rid of it, but you can hear it, but you can't tell where it is. So once again, we have our orchestra here. I'm not going to draw all the instrument names this time, but we have all of our instruments around there. And let's say you have one instrument that's being picked up in one microphone here and one microphone there, and it's 180 degrees out of phase. You will not be able to tell where that sound is coming from. It'll sound like it's coming from everywhere. So if you're making a recording and say, I can't tell where that instrument is, I'd sure like to be able to hear it, especially if like it's a concerto where you have a soloist instrument with the orchestra playing the background, of course, or any kind of place where you have a solo speaker or singer or instrument. If they get out of phase in the two channels, you won't be able to tell where it's coming from. Where you want to make it sound like it's coming from right there, you want to make sure that they're in phase. Just something to watch out for that it keeps coming to my mind. So placement of microphones, that's about the best advice I can give to you at this point, because I'm not teaching a class in audio engineering. Just what do you do if this is dumped in your lap somewhere and you find yourself the expert having to do something that I don't know what I'm doing. And that's just a little bit of help in what you might be able to do there. So what did we talk about microphone impedance? What you need to know is high impedance microphones for high impedance inputs, low impedance microphones for low impedance inputs. If you see that kind of thing, most likely you will be working with low impedance microphones. They will probably have XLR connectors. Be sure not to send phantom power to microphones that aren't designed for it. As far as how they're wired, that should be already taken care of you. That's another topic entirely. If you have things other than microphones to put into your mixer, such as guitars or keyboards, they'll probably have to go through a direct box that has inputs for those instruments and then matches their impedance to your mixer. And your mixer will have multiple sliders for different sounds. What you want to watch for is to keep the levels out of the red. So with all the technical stuff you can know about the impedances and types of microphones, the most important thing is keep the needle out of the red and you will not have distortion. As far as placement of microphones is concerned, it'd be really nice if you had all the channels and the expertise to mix them, to have multiple microphones throughout your group and to mix them together. But if you don't have that option, or if you don't have the expertise, two microphones, but fairly close together, angled to pick up the different sounds. And last but not least, binaural recording. If you have the opportunity, get yourself a foam wig head or something and bore some holes in it and stick microphones in there. I'm going to try that someday to see how it works. But that's just a possible option. But most likely you're going to have a couple of microphones that you would place as I showed if you don't have the option to have others. If you have a soloist, somebody you want to have a definite place and be heard, you may have a third microphone for them and you can put them in the mixer, make sure they're in phase so that the sound is localized to where they are instead of their sound being spread out to where you can't tell where they're coming from. And that's just one last thing I want to talk about, because you might also be expected to have the expertise to set up a home stereo system. Well, I've mentioned some of the things you need to know, such as what are the line inputs and outputs and things are for. Hooking up the speakers. Make sure your speakers are in phase. So your speaker is going to have in the back a black connector and a red connector. And your wires, make sure that your wires are the same for both speakers. Let me draw another speaker over here. So here's your speakers. There's your black input. Here's your red input. It might be screw terminals, might be push terminals, whatever it is. And we want to have our wiring going the same. So there'll be some indication as to which wire is which. Is there a ground? No, there's just a just a positive and negative basically. So we'll say here we have a black wire, and we could have a red wire, but I'll just draw it as a dashed black wire. Make sure that in one channel, if this is going to be, we're looking at the back, so we're looking from the back, so this is going to be your left speaker, this is going to be your right speaker. Of course, if you're looking from the other side and you turn them around, keep that in mind. And you just want to make sure that black goes to black and the other goes to the other. Just make sure that they're the same. Black to black, other to other, or whatever indicator of what these are. Because if you get these mixed up, so let's say we have our black to our red and our other, well, I'll keep that one the same. So it doesn't matter if you flop them both. If I have, well, let me just draw a real quick picture here to show what will work. So I said black to black, red to red. What if you go black to red and the other one to the black? No problem. That will work just fine as long as you're consistent. So they're the same, and the other way, I'll just draw that over here, the other correct way to do it. And so black, black, other to other, positive to positive, negative to negative. That's good too. But notice here I have one speaker, the black goes to the black, and the other speaker, the black goes to the red, or opposite. That is no good. The speakers will be out of phase. So it doesn't really matter which one it is as long as they're together. The speakers will be moving together. And if we switch them, well, they'll just be moving together opposite direction. You can't tell the difference. But if we do this one, we have the speakers doing this. Can you see that? Maybe kind of go down here. Speakers are doing this. One's going out while the other one's coming in. The sounds are out of phase. And you hear that, you can't tell where anything is. And so the way to test that, of course, is to put something in there that's going to both channels equally, like a single speaker, or if you have something where you have a band with one solo singer, you should be able to hear the solo singer right between the speakers. You can also get test sounds to test your phasing, and it will be basically white noise. They'll put white noise in one speaker, white noise in the other speaker, then put it in both speakers. You should hear it in this speaker, then you should hear it in this speaker, then you should hear it dead between the speakers. If you hear it in this speaker, then you hear it in this speaker, then it kind of comes from everywhere behind the speakers, your phasing is flipped. So if you can get some white noise in there, that's a good way to test it. Remember, once again, if the phasing is correct, that sound will come dead between the speakers. Then if there's something like some instruments here, you can hear them where they should be. If someone's walking back and forth, you can hear them walking back and forth. And that is your correct speaker phasing. Another couple of things you may find yourself working with when working with microphones are windscreens and pop shields. Windscreens are somewhat self-explanatory. Microphones don't feel well when wind hits them. You'll get the wind noise. You've all heard it when a microphone gets hit by wind. So almost all microphones come with a windscreen of some sort, usually just a piece of foam. Some microphones have windscreens built in, but may have a windscreen added to them when actually used in a windy condition, such as your popular Yeti microphones. In fact, my microphone right here comes with a windscreen. I don't need to use it indoors, but there it is. So not much else to say about them. Use them in windy conditions. There is another type though, and this is called, depends on who you're talking to, it might be called a blimp or a dead cat. And it looks something like this. It's very furry, which breaks up the wind better than just a foam windscreen. So you'll often find these used outdoors by professional recorders. And of course, if you're using a shotgun type microphone, you're going to need a rather large windscreen to cover the whole microphone. So foam windscreens or blimp windscreens, if you need them, will often be used in outdoor conditions where there may be wind. Another thing you will often see, especially with your favorite YouTube personalities, are pop screens. This goes between the microphone and the speaker, and it's basically for people from Pittsburgh who pop their peas. So these are called plosives, and if you're talking into a microphone, it's very easy for the pressure wave from a plosive sound to hit that microphone and cause it to go off the scale, basically. So to soften those down, you'll find pop screens often used that are on a articulated arm, such as a gooseneck, that can be positioned between the speaker and the microphone. I've never used one myself. Some people might cobble one together with a wire coat hanger and some pantyhose. I have never actually used them, but if you are talking directly into a microphone, you may need them. Okay, so that's about all I can think of for just basic practical application. So I hope you found this useful and informative. If you did, please give me a thumbs up down below. It really helps the channel and helps other people find these kinds of videos. And to help me put these videos online and keep Vocademy free, you can go to patreon.com/Vocademy and pledge your support. A big thank you to my patrons and one-time donors. I couldn't do this without your support. And thanks to everyone for watching.
Channel check. Left channel. Left channel. Right channel. Right channel. Center channel. Center channel.
So what you're going to need is a thing that I forgot what it's called.